In this video, we're going to look at the enzyme that is responsible for fatty acid synthesis. And the 7 reactions we went over in the previous video are actually located on one protein that had 6 discrete active sites. Now there's also 3 sites that don't have any enzymatic activity. We have LD, which is just a linker that connects KS with MAT. And then we have this pseudo methyltransferase and pseudo ketoreductase. That means they look like they should have a methyltransferase and ketoreductase activity based on their structure, but they don't do that anymore. Now, to make a fatty acid, the protein, 2 copies of the protein, will come together to make one structure. And they will interact at the KS, the DH, in the E domain to make something that vaguely looks like an X. The lower portion of our X, that's where our condensing activities of MAT and KS are located. Our upper portions, that's where our beta carbon modifying activities of DH, KR, and ER will be. And our C-terminal ends have the ACP and TE, and they're very flexible. So we don't actually see those in our crystal structure because there's too much movement, so they don't crystallize well. But they are there in the real thing, just not in our picture. Now, our 2 reaction chambers, because there's 2 enzymes, they are lined by a full set of catalytic domains from one subunit. And all of these sites can be reached by our long phosphophantylene arm of ACP that we talked about in the previous video. This is the thing that is moving malonyl coenzyme A around to visit these different sites. And you actually have catalytic sites both on the front and back faces of this enzyme, which means you can make 2 fatty acids at once. Now, if you're well fed, you're going to have fatty acid synthesis proceed at a low rate. While certain tissues, like cancer, will have a lot of this fatty acid synthesis being made, they'll produce fatty acids at extremely high rates. So one way you can think about inhibiting cancer is that you inhibit fatty acid synthase. Sure, you're going to hit your healthy cells as well, but since this is overexpressed in cancer, you should have a bigger effect on cancer cells. And that's it for this video. I will see you in the next one.